Hello everyone. The topic of this lesson is the two-stage crude oil electric dehydration process. An emulsified interfacial layer forms at the oil-water interface in crude oil, primarily composed of water and oil and water emulsified particles, flocks, etc. These flocks mainly consist of wastewater, asphaltenes, resins, waxes, and inorganic salts, posing significant challenges to demulsification and desalting. The desalting unit is the primary step in petroleum refining, mostly employing a two-stage electric desalting process. To improve the desalting rate, some companies adopt a three-stage electric desalting process. This is analogous to washing clothes. If clothes aren't very dirty, 2 washes might suffice. If not clean after 2, a third wash is needed. First, let's examine the two-stage electric desalting process flow. Most refineries use the two-stage electric desalting method for crude oil desalting and dehydration. It comprehensively utilizes heating, adding demulsifiers, and high-voltage electric fields to break the crude oil emulsion, coalesce water droplets, and achieve separation by settling. Let's look at the diagram on the left. This is a schematic of a two-stage electric desalting process. After crude oil enters the unit, a demulsifier is injected at 20 to 50 ppm relative to the crude oil. It is heated by 5 to 7 desalting heat exchangers, reaching a temperature of about 130 degrees Celsius after heat exchange. Fresh water is then injected, and the mixture passes through a mixing valve to thoroughly mix the crude oil, water, demulsifier, and impurities. The mixture enters the first-stage electric desalter from the bottom. The pressure in the electric desalter is controlled at about 1 MPa. Metal electrode plates are installed inside the electric desalter. The upper plates are grounded, the lower plates are charged, creating a high-voltage electric field between them. Under the action of the demulsifier and the high-voltage electric field, demulsification occurs and water droplets become polarized. Small droplets coalesce into larger ones. Once they reach a certain size, due to the density difference, the water droplets pass through the oil layer and settle to the bottom of the vessel. As water is conductive, a weak electric field forms between the lower charged electrode plate and the water layer, promoting further oil-water separation. This achieves the purpose of removing water and the salts dissolved in it. After passing through the high-voltage electric field, the dehydrated crude oil is drawn off from the top of the vessel. Fresh water is injected again, mixed via a mixing valve, and the mixture enters the bottom of the second-stage electric desalter. It passes through the high-voltage electric field again for dehydration. The dehydrated crude oil flowing out from the top is the final dehydrated crude oil. Water from the bottom of the first-stage electric desalter is continuously discharged automatically via automatic control. Water removed from the second-stage desalter has lower salt content and is reused as the injection water for the first stage before desalting, conserving fresh water. The water discharged from the bottom of the first-stage desalter sometimes has a salt content as high as 400 mg per liter when leaving the unit. The first stage has a desalting efficiency of about 97% and bears the main responsibility for salt removal. Water must be injected before crude oil enters both the first and second stage desalters. The purpose is to dissolve crystalline salts in the crude oil, increase the water content in the crude, and enhance the dipole coalescence of water droplets. Typically, the injection rate for the first stage is 5% to 6% of the crude oil flow, and 2% to 3% for the second stage. Water injection is required before both stages, resulting in very high water usage. Therefore, in industrial production, it is necessary to continuously improve the process and particularly emphasize water conservation. Green chemical engineering is the trend and practical requirement for industry development. When working in the chemical industry, we should advocate for green chemistry, prioritizing water saving. We should use advanced chemical technologies and methods to reduce resource consumption, promote product upgrades, and foster the healthy and sustainable development of the chemical industry. Next are the main equipment for crude oil electric desalting. The main equipment includes the electric desalter vessel, mixer, transformer, oil-water interface controller, etc. The electric desalter vessel is one of the main pieces of equipment. It comes in several forms such as horizontal, vertical, and spherical. Refineries domestically and internationally generally use horizontal vessels. A horizontal electric desalter mainly consists of a shell, electrode plates, a crude oil distributor, a collecting header, and a water drain collector. The shell diameter of an electric desalter is about 3 to 4 meters, and its length depends on the processing capacity, sometimes reaching 20 to 30 meters. The electrode plates inside the desalter are generally arranged in 2 or 3 layers. Too many electrode layers and excessively small spacing not only reduce desalting efficiency but also increase power consumption. The function of the crude oil distributor is to ensure that the crude oil, after entering from the bottom, flows upward uniformly and vertically, thereby improving desalting and dehydration efficiency. The collecting header located at the top of a vessel collects the desalted crude oil and sends it out of the electric desalter. The water drain collector is located at the bottom of the vessel, collecting the water settled there and discharging it from the vessel. Before entering the desalter, crude oil needs to pass through a mixer where oil, water, and emulsifier are thoroughly mixed, dispersing the water and emulsifier finely within the crude oil. Fine dispersion leads to high desalting efficiency, but there is a limit. If the dispersion is too fine, forming a stable emulsion, the desalting rate can actually decrease. Therefore, the mixing intensity must be appropriate. Maintaining a relatively stable oil-water interface level within the desalter is one of the key factors for successful electric desalting operation. A stable interface maintains a stable electric field strength. Furthermore, interface stability ensures the required residence time for the desalted water in the vessel and guarantees that the oil content in the discharged water meets specified requirements. Electric desalters are equipped with electrode plates. For horizontal plates, there are 2 main configurations: 3-layer electrode plates and 2-layer plates. The plates are coordinated with the transformer configuration, divided into 1 to 3 sections. For the 3-layer configuration, a single polarity power supply is used. The middle layer of the 3 plates is energized, while the upper and lower plates are both grounded. The distance between the upper and middle plates is typically 200 to 220 millimeters, constituting the strong electric field zone. The distance between the middle and lower plates is typically 500 to 540 millimeters, constituting the weak electric field zone. The 2-layer configuration also uses a single polarity power supply. Instead of adding a lower plate, the interface of the bottom water layer is utilized as a grounded electrode plate. However, if the oil-water interface fluctuates significantly, it affects the stability of the weak electric field, which is detrimental to desalting and dehydration. To effectively remove saline water, a 3-layer horizontal electrode plate configuration is generally used in practice. Below the lower electrode plate in the electric desalter, a crude oil inlet distributor is installed. The distributor's function is to distribute the crude oil uniformly across the horizontal cross-section of the vessel, allowing the oil-water emulsion to rise evenly through the electric field. One type is the pipe distributor, with small holes distributed along the pipe, suitable for crude oil with low viscosity and few impurities. Another type is the inverted trough distributor, with holes around its perimeter. This type is suitable for crude oil with higher viscosity, more impurities, or heavy crude, as it helps avoid clogging of the distributor. Most refineries use the inverted trough distributor. The above covers the entire content of the two-stage crude oil electric desalting process. This concludes the lesson. Goodbye, students.